Exponential form looks like this. And an example is 3 squared equals 9. Now, another way to write this is to transform it to put it in logarithmic form. So if I were to write this same exact thing into logarithmic form, my base is 3, that goes down here. The answer was 9, and my exponent was 2. What this says is log base 3 of 9 equals 2. What this means is 3 to the power of 2 will give you 9. Another example of a log. Log base 5, the answer is 125. The exponent was 3. What this means is 5 to the power of 3. 5 to the power of 3 is 125. So logarithms and exponential functions, we can go from one to the other and back and forth. So let's convert these logarithms to exponential equations. This says 3 squared is 9. 3 squared is 9. 6 to the power of 3, or 6 cubed, is 216. 7 to the power of 0 equals 1. This is a rule. Anything to the power of 0 equals 1. You have to memorize that. Okay, this one says 4 to the power of negative 2 is 1/16. Now, this is another rule. Whenever you have something to the negative power, you can flip it and make it positive. Okay? So in this case, they flipped it. They put the 4 squared in the denominator, and now it's positive. 4 squared is 16. So these are some rules that we're going to have to remember. So for example, if I say log of 5 and I get 1/25, that means it had to be negative 2. 5 to the power of negative 2 is 1/25, because this goes into the denominator. Okay, now let's convert exponentials into a log. Your base goes here, the answer goes here, the exponent goes here. 14 squared is 196. This is log base 12. Whenever you have the base matching the answer, it's always going to be 1. So if I say log base 20, this is 1. Because anything to the power of 1 is just itself. This says 36. So log, my base is 36. The answer is 6. The exponent is 1/2. That goes there. Okay, so we converted exponentials to logs. Now let's talk about the common logarithm. The common logarithm is when your base is 10. So the common log is when the base is 10. If the base is 10, you don't have to write it. So you don't have to write 10. You don't have to write the base if it is 10. So you can just write it like this. So for example, let's say I have log of 1,000. What would the answer be? The answer is 3. The reason why is because you can imagine a 10 right here. So 10 to the power of 3 is 1,000, because 10 times 10 times 10 is 1,000. We did it 3 times. So that's to the power of 3. So let's evaluate these logs. This is 2, because 7 squared is 49. This is 3, because 3 cubed is 27. 3 times 3 times 3 is 27. This is -2, because 9 to the -2 will give me, I know 81 will be in the denominator since this is negative. This one's a little bit complicated. Notice I didn't get bigger. Normally when you do something to a power, it gets bigger, right? All of these got bigger. From here to here, it got bigger. However, here it's a little bit different. The answer here is 1/3, and I'll show you why. This is 64 to the power of 1/3 gave you 4. 64 to the power of 1/3 will give you 4. Okay? Whenever you see a 1/3, you can write this as a cubed root. So you have to ask yourself, what number multiplied by itself 3 times, because this is a cubed root, 3 times will give you 64? Well, the answer is 4, because 4 times 4 is 16, times a third 4 will give you 64. Okay? So this is something you have to remember or recall. Recall that the square root of x is the same thing as x to the 1/2. The cubed root of x is the same thing as x to the 1/3. The fourth root of x is the same thing as x to the 1/4, and so on. So basically the rule is this. If there's an n right there, you can write it as 1/n. Here, it's known that it's a 2. You don't have to write the 2. Okay, you will probably never really see people writing a 2 right there. It's imaginary. Okay. Now we're going to talk about the product property. The product property says if you have 2 things multiplied together, you can separate it. This is log base b of m plus log base b of n. Now, this is a subscript. Means it has to be in the bottom. It's going to be in the bottom of it, okay? It's not in line. These are subscripts. I see a lot of people writing it like this. This is not correct. The B needs to be down here. It's a subscript, okay? That's not right. Please don't do that. Okay, so let's use this rule. Well, if I have this right here, the bases are the same. They're both 2s. So we can multiply these, right? You have 2 different things with the same base. Multiply them together. You have an m over here and n over here. Multiply them. That's what this rule is saying. So I'm going to say log of base 2, and I'll do 7 times 4, which is 28. Condense means to make it smaller. So I went from 2 logs to just 1 log. I condensed it into 1. Let's do this one. Your bases are the same, and you have a plus sign, just like my rule says I need. So I'm going to combine it. This is log base 4, and I'm going to multiply these 2. 2 times 4 is 8. X times x squared is x cubed. So this is my answer. So that's how you condense using the product property. Now I'm going to expand. So I'm going to write this as more than 1. So I can do, I'll just set it up real quick. I can do 9 times 5 will give me 45. Oh, I can condense this further. This can be log base 7 of 3 plus log base 7 of 3, because 3 times 3 will give me that 9. And I still have log base 7 of 5. So this is it fully expanded. Uh-oh. And notice 3 times 3 is 9, times 5 is 45. So that is your answer expanded. Now let's do the quotient property. The quotient property says if you have two things being divided, you can write it like this. Log base B, you should write it small and at the bottom, it's a subscript, minus log base BN. Notice the difference. This one has a subtraction sign. The product has a positive sign, a plus sign. It's an addition. Okay, so let's apply it. Your bases are the same, so we can condense this. This will be log base 3, 24 divided by n. We're doing 24 divided by, 8, m over n, 24 over 8. This is just 3. So 24 divided by 8 is just 3. So that's my answer. And of course, guys, remember, this is just 1. All right, this one. The bases are the same, so I'm going to put log base 4 x to the 9th over x squared. That's just log base 4 of x to the 7th. Those are examples of condensing. Notice I had several logs and I condensed it into one. Several logs and I condensed it into one. Now I'm going to expand it. So let me think. What divided by what gave me 4? I can do 16 divided by 4 will give me that 4. You could say 8 divided by 2 gave you 4. Those are all fine. Okay, so that's the quotient property. The last property is I have this wrong on the slide. The last property is the power property. The power property. So what this says is my exponent can come to the front. So you can write it like this. N times your log base B of n. Power property says your exponent can come to the front and be the coefficient. This is the power property. And vice versa. You can go from here, put the n on the top and put it back. You can go back and forth. So for example, I'm going to condense it. So I'm going to make this a little tighter, put this right here. So this will be log base 4, 2 to the power of 5. Well, 2 times 2 is 4, times another 2 is 8, times another 2 is 16, times another 2 is 32. That's 1, 2, 3, 4, 5 2's. So this is log base 4 of 32. This can come up here. So this is log base 2 of x7, x to the power of 7. This can come up here. This will be log 8 to the 1/3. Now remember, this can be written as the cubed root, okay? I rewrote the 1/3 as a cubed root. Now, you have to ask yourself, what number multiplied by itself 3 times is 8? That answer is 2, because 2 times 2 times 2 is 8. So this is log 2. So that was condensing. Now we're going to expand using the power rule. Remember, this can be written as W to the power of a half. Remember, square roots can be written with an exponent of 1/2. Using the power rule, this can come to the front. So this will be 1/2 log base 7W. Now let's put it all together. So we have this problem. Actually, I'll come back to that one. Let's do something like this. So I'm going to remember PEMDAS. This is my order of operations. I'm going to start with the parentheses first. So inside of my parentheses, I'm going to do the product rule. I know it's the product rule because they're being added. 2 logs are being added. The product rule says I can do log base 5, 8 times 27. Let's see what that is. 216. And then I have a 1/3 minus log base 5. Okay, next I'm going to apply the power property. The power property says this coefficient can come up here. So this will be log base 5 of 216 to the power of 1/3. This part stayed the same. Now remember, I can rewrite 1/3 as a cubic. So this is log base 5. I'm sorry, I can write it as a cubed root. Okay, well, I know that 6 times 6 times 6 is 216. So that means the cubed root of 216 is 6. So this is log base 5 of 6. That's what that simplified to. Minus, I'll bring this down. Now, this is the quotient rule. I know this is the quotient property because there's a subtraction sign. The bases are the same, they match. So my answer will be log base 5, I only need one of them. 6 divided by 3 is 2. That's your answer. Let's try this one. I'm going to expand this. I'm going to follow my order of operations. Let's take care of these parentheses. Well, I can't really simplify anything in here because these are all different variables. They're all different letters. So I can't really do anything. Let's go to exponents. I can distribute this. So this will be log base 2 of y squared over z to the 10. Because I distributed the 2, the exponent. Okay, so now I'm going to do the quotient rule. I'm sorry, I keep saying rule. It's the quotient property. So these are being divided. So that means I can do log base 2 y squared minus log base 2 of z to the power of 10. That's the quotient rule. Now I'm going to use the power property. And guys, I'm sorry, I keep saying the word rule. Whenever I say rule, just know I mean property. Okay, so now I'm going to use the power property. The power property says I can put the exponents at the front. Exponents at the front. Don't leave those exponents up there. Use the power rule. So your answer will be 2 log base 2 of y minus 10 log base 2 of z. This is your answer. We expanded this. Let's try this one. Remember, I can write this root 4 as a 1/4. So this is log base 3 m5 n squared, but all of this to the 1/4. Since all of it was underneath the root symbol, all of it will be included for the 1/4. Okay? That's how I rewrote it. So I'm going to write the word rewrite. That was my first step. Okay, now I'm going to go ahead and distribute this. So this will be log base 3 m to the 5/4 n to the 2/4. And guys, this can be simplified. I can write this as 1/2. Always simplify your fractions, or else we'll get the problem wrong. All right. Next, I will do the product property. So these two are being multiplied together. I can write them as separate logs. So I'm going to do log base 3 of m to the 5/4 plus log base 3 n to the 1/2. Now I'm going to use the power property. The power property says if you have an exponent, bring it to the front. So my final answer is 5/4 log base 3n plus 1/2 log base 3n. That's the end. Let's try another one. Okay. This is the quotient property. You have division, so we're going to use the quotient property. So I'm going to say log of y root z to the 5th minus everything that's in the bottom, log x to the 5th. All right. Now let's look at this front one. I have these two being multiplied, so I'm going to split it up. This is the product property. So I'm going to say log y plus log root 3 z to the 5th. And then don't forget we're subtracting log. Can I bring this to the front, guys? This is the power property. So I'm going to say 5 log x. Okay. Now remember, guys, I can write this z to the 5th. I can write this to the 1/3. Remember? Roots can be written as a 1/3 roots. I'm sorry, cubed roots can be written like that. So that's what I'm going to change. And everything else can just come down. Guys, I'm going to use the power rule again. I'm going to use the power property. This 1/3 can come to the front. So I'm going to write it right here. With the 1/3, I'm going to put it in the front. So that's gone. It's in the front. Oh, and I can use the power property again. Look, I have a 5 right here. I'm going to bring that to the front. Okay, great. So I brought the 5 to the front. All right, so let's see what I have. I have log y plus 5 times 1/3 is just 5/3. Log z minus 5 log x. That's my final answer.